One of the most important requirements for geoscientists is the ability to visualize their data. And with these integrated data sets across a number of scales, it's even more challenging to create a system that is intuitive and allows them to develop insights as they look at, classify, and interrogate the data. Virtual Core provides an integrated visualization environment that allows geoscientists to see all this data in one place, aligned across a number of different scales. The main visualization window of Virtual Core shows core photographs, core CT scans, analysis data such as computed bedding curves and so on. Histograms of the CT number show the distribution of rock material that's in the core. The cylinder unwrap provides a view of the CT values extracted around a circumference in the core that can be compared with well-bore images. The high-density projection provides a view into the interior of the core, allowing you to see internal structures like bioturbation and fractures. You can also view any imported data here as well, such as well logs, well-bore images. Thin sections can be viewed here as well, showing where they're located in depth, along with plug testing results and micro-CT data associated with this depth location. This view is easily customizable. You can easily show and hide different tracks. There is a mini-map that provides an overview of the entire core data set, allowing you to easily navigate to different regions. In the bottom right corner, you can see, as you explore the data, the transverse CT slice that's associated with that data region. This view is fully customizable. You can easily drag these tracks around, change the order they're displayed in, overlay one on top of the other, and easily select which ones to display. The visualization tool contains the notion of well tags, which makes it easy to annotate regions of core, and also import other data that's associated with certain depth locations, such as thin sections, plug testing data, and so on. Well tags can be used to indicate specific locations that might be of interest, allowing the geoscientist to indicate bioturbation, for example, or an interesting fracture or feature. Interval logs make it possible to label a depth range of core, for example, for lithofacies analysis or core description and so on. These annotations are all stored in the atlas, which collects all of these and provides a reference system for easy navigations to different locations in the core. These annotations are all stored to the centralized server, allowing geoscientists to share their observations with one another, allowing for greater collaboration. In addition to visualizing 1D well log data and 2D images, Virtual Core has a 3D visualization tool that allows geoscientists to see into the interior of core. Often, core CT scans represent the best data for this. The 3D visualization system gives the geoscientist tool to easily highlight different features within the core. The curve along the bottom is a histogram of all the CT numbers in the core. So the region to the left represents low CT numbers or the relatively less dense material. As we move over to the right, the material is more dense. So we can create small transfer functions to highlight different regions. So here we're showing a section of less dense matter within the core. And this highlights some interesting patterns in some of the bedding planes. As we move this over to the right, we're highlighting successively more dense material. Eventually we reach this peak here in the histogram of CT numbers. And this is the rock matrix, so everything gets very bright and washes out. As we drag it a little bit further to the right, we can see that these bioturbation features present themselves. And we can go back in and later add second transfer functions to highlight the bedding planes and create these composite images. Once we're happy with the visualization, we can save this back as a well tag in the core, and it will appear as an atlas. And anybody else visualizing this data set can see this visualization that we created, add their own comments, and etc. The flexibility of Virtual Core allows us to add custom visualization tools for different types of data. For example, we've added a thin section visualization tool that allows us to view gigapixel multipolarization thin section images in a very convenient manner. This gives geoscientists the ability to look at thin sections and core and well log data in the same application, saving them time from switching between different platforms. By its nature, geoscience is a very visual discipline, and Virtual Core provides tools that allow these types of geoscience data to be viewed in one place, allowing new conclusions to be drawn, and providing the facility for geoscientists to collaborate with one another on the same data set.